GFG problem, that is power set, and it is marked as an easy category problem here. Let's get to the problem statement, which states, given a string S, find all possible subsequences of string in lexicographical sorted order. And by this, what do we mean? Let's say, suppose, let's take a smaller example right here, which is A. So we need to have A, and A. And there is also an empty substring, but they have not taken it right here. So let's say if an example is A and B, what will be my output? So I'll just write it here, and then I'll be drawing it and explaining it to you how it goes. So let's say if in the question it has been given A and B. So what do we have as an our answer? That is B, A, B. This is what our answer will be. And there is also an empty substring which is there. So which is not included in this answer right here. Since it is mentioned in the question that we do not need to take a non-empty subset here. So that is why we'll simply just generate all the subsets. Now let's see this problem in a much clearer way, how we can solve to it. Okay, I'll just show this. So I've already drawn this on how to do it to save some time. So whenever we have something like this as a power set or generate something, we know that first of all, what is the length of the substring? Let's take an example, that is a smaller example. So we will have 2 to the power n subsets, and this is a general rule. So 2 to the power n, which is, if the length is 2 right here, what will be my subset? It will be 4, right? But only here the answer has been given as A and AA. Why so? Since they have not included the empty set right here, that is why the answer is 3. Otherwise the answer would have been 4. That is, a blank string would have also been here, something like this. Okay, so generally we have 4, but they have not included it. They have change the question a little bit, just a little bit. So let's say, suppose my example is this. So I would be having an empty subset A, and A as mentioned here. So how do we actually go generating this? So we can use recursion and backtracking as well as bit manipulation here, and I'll be using bit manipulation here to generate all the subsets that we can for the given question. So now let's get to the problem. Let's say we have an question string that is given to us as AA. Now how can we generate it? First of all, if we look at the binary representation, we will get how we can generate it. So what is the binary representation for 000? That is 0, right? And this is 001. That means what? 1. Again, 010 means 2, and 011 means 3. And why have I written this? That could be your question. Now let's see. We knew that we had 4 right here, right? We need to generate 4 subsets. Since we are not including the blank subset, now it decreases to 3, right? So this is what we have to represent. Now let's say if I want to represent this as a binary or a bit mask, how can we do it? If you observe carefully, we get something like this. So 000 is empty, right? This was empty subset right here. Now A. Now we go from right to left, remember. So what is the position of this guy right here? This one is 0. So I'll just mark on the positions of this. So this guy, I'm saying this will be my 0th index, this will be my first index, this will be my second index, which is not present here since the length of the string is 2. So for a 0 based array or a string, we will have only 2 indexes, that is 0 and 1. Now let's get to how this is actually giving my answer. Now I said I need 1, right? So I said all of these indexes and these ones are representing that this is what I have to choose from my string. Okay, so 1 means I have to choose this from my string, 0 means I do not have to choose this from my string. Okay, so I'll just write this down here. That is my string. This is representing A, and this is also representing A. So this is what it is representing. I'll just draw a line here for more clarity. And okay, and this should be more clear by now. So how we are getting it? So when I generate the mask for the 0 we get, we do not need to include anything from my string. Fine, not a problem. When we go for 1, so 1 is represented in binary as 001. So this is the binary representation of 1. I hope you know this. This is the prerequisite for this question. So I will not be explaining that, since this video will become too long. So that is why I'm just explaining the answer for this question. So the binary representation of 1 is this guy right here, that is 0 0 and 1. And see, there is a 1 that is set in which position, that is the 0th position, right? So I will say I will take the 0th position character from my string, which is what, which is a. So I will say I will take in a. Okay, fine by me. Now let's get to 2. Now when I go to 2, I see that there is a bit set. By bit set I mean there is a 1 at this first position. So I will say, okay, from my array or my string, I will take this a of the first position, that is this guy. So I've taken these two, right? Fine. Now when I go to 3, and what is this 1 2 and 3, from where are we getting this? This is nothing but the length of the string that we get, and also the generated 2 to the power n combinations that we find here. So we will be first generating what is the number of subsets that we can form, which is given by the formula 2 to the power n. This is from where we are getting this 3, right? So 0 1 2 3, and we are starting from 0 here. So, and since we do not need to include the empty subset, we can just start directly from 1 right here. This is the important thing in this question. So now let's get to the third one. So three's binary representation is something like this, that is 1 0 1 1. Okay, and we see at the 0th index we have 1, and the first index we have 1. So what we will do is we will take this a from the 0th index, we will take this a from the first index. So what do we have right now? We have something like aa. So this is what we get, something like this, and we store it in a vector. And this is nothing but my answer which I needed. If you carefully watch this, you'll get it. This is nothing but my answer. Okay, and this empty substring is not needed here. So we just do print this answer, or we just return this answer. And mind you, here it has been written that we need to give the subsequence in lexicographically sorted order. So if you just sort at the end after the vector you get, which is your answer, you will get an AC. So now let's get to the code, how we have done it. So as I explained there, the code what I have done here is, so let's get this pen right here working. Okay, so what is this? This is nothing but the length of the string. I guess this will not work now. Fine. So I'll just write it here. This is nothing but the length of the string, length of string. This is length of the string, and this is what? This is the power that I calculated, right? I showed it to you. We were finding the 2 to the power n power while I was explaining. So this is what we are finding. This is one left shift, the length of the string. You can also write something like power of, that is inbuilt library for finding 2 raised to power something, or x raised to power something, right? So what do I do here? I just say I need power to raised to the power length, right? So length comma 2, this is what I write, and this is equivalent to this thing that I have written here. And this is my vector that will be returned at the end, right? Since the return type is vector of string. And what do I get here? That is for int top put is equals to 1. So the naming convention that I followed is pretty bad here. So just remember, this is from 1 to sz minus 1. And what is this sz? It is nothing but 2 to the power n that we had calculated, and we are taking a temporary answer here. And after that we are saying 0 to length we will go. Okay, after we go from 0 to length. And why only from 0 to length we are going? Since we know the length is the length of the string here, that is why we are going from 0 to length. After that we go and find the bit mask of this. This is the formula for it, that is to put, that is this guy right here. I'll create a mask of this, and this will say if this bit is set or not. If this bit is set, then we will add it to my answer, and at the end of this loop we will just push it back into the vector and sort it and return the answer. And that will be it for this video. Let me just run this and show it to you. This is a submitted code already. and this will give you a correct answer. And yeah, that is it for this video. Thank you for watching.